Okay, well, good afternoon, everybody. It's a beautiful day out here in the sunshine, and we're here to talk about solving compound inequalities. That's our goal today. Kind of calling these a level one because just to solve them, they're going to be one-step problems, and then we'll do level two on the next video. And we're going to go for 4 examples. One of our big goals is to improve our capacity to graph, but also to distinguish between and or and the meaning of those things with respect to inequalities. So our first one here is an or. So I'll read it. It says p plus 5 is less than or equal to 5, or 3p is greater than 9. So we're going to have 2 boundaries here defined by the or. So we just treat them separately at first. So let's go for this one. I got to subtract 5 from both sides, right? So I got p is less than 0. Remember, when you add or subtract, you never flip the inequality. So I just left it. It was a less than. It's still less than. Now I'm going to move over to here. I'll bring down my or. 3 times p has to be greater than or equal to 9. So what I have to do here is divide by 3 because I want to isolate the variable. So if I divide both sides by 3, I get p is greater than or equal to 3. So I have 2 conditions and we got to graph them both. So let's get a number line here and let's find 0. All right. Now it says less than or equal to 0. So p could be -1. It could be -1,000,000 or -1,000,000,000 million trillion. It's all good. So what I'm going to do is I'm going to put a circle. I'm going to put an arrow that direction. Now it says less than or equal to. So when it can be equal to, we have to fill in the 0. All right, let's go over here to the 3. I'll put the 3 right there. And it says greater than or equal to. I'm going to keep using blue. And we go that way there. Okay, so you can see why we use the word or, because you can't be both. There is no number. There's no number that is less than 0 and also greater than 3. There ain't no number like that. We ain't got no numbers that are less than 0 and also bigger than 3. And so because it cannot fulfill both conditions, we call it an or. All right? Thumbs up. Okay, let's move on to another problem. And by the way, this thing here, it's only leaning up against a chair. So it might fall on me. That's if the wind picks up, this thing's gonna fall on me. So if it starts falling on me, you've got to warn me. You gotta say, hey, Mr. Miller, a board looks like it's about to fall on your head. All right, so let's go here. And less than 4. And this is supposed to be a 7. Okay. All right, so we have, again, it's a compound inequality because the word compound implies there's more than one inequality. And generally for us, we're seeing 2 inequalities. So we have -7 is less than or equal to -1 plus x, which is less than 10. So 4. Where I got 10 from? I'm tripping. That's where I got it from. And we want to isolate the variable. Now we could write these as 2 separate inequalities and work them separately. That's one option. We're not going to do that option, but it's possible. We could say, all right, well, it's like this. And you could write the other one. Okay, but I'm going to do it as, just leave it as one inequality. So watch this. I want to isolate the variable. So what I got to do is I have to add 1. Now, if I add 1 here, I'm going to have to add 1 to this side. But you notice there's like another side over here too. There's that inequality where you have to also add 1. So what you're left with is -7 plus 1 is -6. Again, less than or equal to, that's not changing. Negative 1 plus 1 is 0. So we have x, which is less than 5. So there's the final solution. We have negative 6 less than or equal to x, which is less than 5. And we have to graph this. Okay, so that's the answer. If all I asked you for was the solution, you are correct here. But if you have to graph it, let's find our two boundary points, 6 and 5. Now what we want is we need x to be bigger than negative 6. Now it could also be equal to, but it has to be less than 5 as well. And so that's your classic and. When we use the word and, that means it has to, what is it? Kind of qualify or satisfy. That's the word I was looking for. It has to satisfy both boundaries. So you can be greater than negative 1 and also less than 5. You can be both. And so this is a situation where we have an and. All right. So an or, you can't, satisfy both conditions at one time, but you can with an and. So and just like that, it's written. How about that? Amazingly fast. So what we're going to do here is, again, we're going to be sitting with this and situation. We have it written as one continuous inequality, and we're going to multiply everything by negative 4 in order to get the variable by itself, right? Because that's going to reduce to 1. And so we're going to get 4. Oh, my dog must have seen a cat in the field. You're good, Olive. You're good. All right, so we're going to say flip the inequality because we multiplied by a negative. That gives us m. We're going to flip the inequality because we're multiplying by a negative. We get 0. So m has to be between 4 and 0. It's got to be less than 4 and greater than 0. So if we were to graph this, let's put our boundary points. Now it can't actually be 0 or 4, so it can't be the boundary. It has to be bigger than 0 or less than 4. And so you'd want to fill in every value in the middle. And it has that classic look of an and, because every point that you put on as a solution can satisfy both conditions. So now this is not a solution. Negative 1 is not a solution. Sure, it's less than 4, but negative 1 is not greater than 0. So it doesn't satisfy the and nature of what this question is about. All right. I'll try that again. Boom, all done. How about that? I'll tell you, I told you I was going to write it quick. So here we have the or situation. Nice thing about an or is, it's kind of nice for treating them separately, because that's kind of the nature of the or. Do this one or this condition over here. Let's start with this condition, which says 2 times the variable b. Okay, so look, that's a b. That ain't a 6. Okay, so my b's got this real, every once in a while people are like, Mr. Miller, that's a 6. No, that's a b, all right? So we got to divide by negative 2. So that means b. I'm going to flip the inequality because of the division by a negative number. 6 divided by negative 2 is negative 3. I don't know why I switched to blue on the negative 3. I'm going to keep to black. Over here, I got to add 10 because this is b plus negative 10. So really, I should take away these 10 negatives. But remember, when you take away negative, that's the same as adding. So a lot of times students here will just say, oh, they see the minus 10, so they just add 10. But adding 10 is the same as subtracting negative 10. All right, so we get b has got to be greater than 2 plus 10 is 12. I'm going to bring down the or. Beautiful. Lovely. All we're left to do now is we have to graph this thing. If I was just asking you to solve it, you've solved it. Now, let's go here and let's find our boundaries. Okay, very, very nice. Let's put an open circle because it can't actually be negative 3. It's got to be less than. or greater than 12. And so here is kind of the nature of the word or, that 13, for instance, is now a solution because it is bigger than 12. And sure, it ain't less than -3, but it doesn't have to be. Solutions have to either satisfy this condition or that condition. And that's how we roll. That's the game we're playing, okay? Well, the sun's in my eyes, so hopefully that means that you could see the board. Hope you have a beautiful rest of your day. Hope this lesson finds you in a nice place, finds you well, and take care, and I'll see you around.